12.6 small increment and approximation. Okay, we know that the gradient of tangent is dy dx. And at the same time, we know that gradient of a straight line is y2 minus y1 over x2 minus x1. So over here, we have a graph. Over here, we have a curve. We have the P and Q here. P is x, y. Q is x plus del x, y plus del y. So if we have a axis, x-axis and y-axis here, let's say if we have the x and y axis here, okay, then this is y, this is x, this is x, and over here is x plus del x. So the base here is del x, and we have the y and the y plus del y, and the height here is the del y. Okay, so we know that the del x is small changes of x, and del y is a small changes of y. That means this q is very close to p. When it is very close enough, okay, to uh, around zero, approximate to zero, then it will become the dy dx. Okay, so the gradient for this case is the y plus del y minus the y over the x plus del x minus the x. So y minus y cancel, then we have the del y over del x. Okay, so we know that actually the first principle, this one, okay, actually you should learn at the very beginning, but it's not covered in our syllabus. Later, when you go to the higher level, then you'll learn this first principle. It say that dy dx is actually the limit of del x to 0, del y over del x. So over here, we can say that the del y over del x is approximate to dy dx. Okay, del x is a value. So this value we can multiply to the other side. Then we have the del y approximate to dy dx multiply with del x. Okay, so what is important here is this. Okay, so we look at the example number 6. Variable xy connected by the equation y equal to 3x squared minus 4x. Find in terms of p the approximation in y as x increased from, so x increased from 5 to 5 plus p. So this is actually x. This is the x plus del x. So if we want to find the del x, it's the 5 plus p minus the 5. Then it is p. And x is equal to 5. So we have the dy dx is 6x minus 4. Okay, so dy dx when x equal to 5, 6 times 5, 30, minus 4 is 26. So we know that del y over del x approximate to dy dx. So the del y approximate to dy dx times the del x. So this is 26p. Okay, 26p is the answer. Okay, why? Because the del x here is p. Del x, small changes of x is p. And the dy dx here is the 26 here. 26, this one. So the answer will be 26p. B, we want to find the approximate change in y as x increased from 3 to 3.01. So for the B, the x is from 3 to 3.01. So we have x equal to 3. And the del x is the 3.01 minus 3, which is 0.01. So we have the dy dx when x equal to 3 is 6 times 3 minus 4. So 6x minus 4, 6 times 3 minus 4, 18 minus 4, 14. So the del y approximate to dy dx multiplied with del x. So this is 14 times 0.01, then is 0.14. Okay, so this will be the answer. So over here, the del x is 0.01 and the dy dx is 14. Okay, that so what important here is the del y, del x approximate to dy dx. So the del y, small changes of y, approximate change in y is approximate to dy dx multiplied with del x. Okay.